Ay, nako. Nakakaloka. Oh, Jude. Hello, guys. Oh my gosh.
The Bluetooth device is ready to pair.
Hello, welcome back to my YT channel. This is again your YouTube content creator. I am a singer, a trainer voice. Now we go to my number 3 segment, okay, of this beautiful Saturday of live streamings, simultaneous live streamings of Facebook and YouTube. Okay, thank you so much for my audiences, okay, that are watching. And then you can also take down notes if you are presently studying this particular topics in your classroom instruction. Okay, and this will be also your reference if you are being able to take different types of examinations pertaining to pure sciences, particularly chemistry also. So here we are not teaching you to solve directly or in a straightforward manner. Here we are discussing the appropriate way or proper way how to discuss, and then using the formulas in a detailed fashion. It looks like a spoon-feeding attack of discussion to really understand and to absorb the basic foundations of mathematical problem solving in pure sciences, particularly chemistry. Now, this is all about Hess law, the constant heat of summation, in which this is the enthalpy change for the reaction is equal to the changes of the heat involved in our system or in our surrounding, something like that. Okay, so this is question number 3. Actually, this is really a question. This is only an example because there's no word statements, blah blah blah, so and so. I am showing to you now the chemical reactions involved, and then you can compute what is being asked. Okay? Now this is gonna be calculating the overall heat of reaction, or delta HRXN. Okay? So in chemistry, we denote RXN means reaction or chemical reaction. RX and small letters R, X, and N. Okay. So delta H, R, X, N is unknown, question mark. Okay, now we have equation 1 here. Okay, take a look. Equation 1. Oh, this is number 3, sorry guys. Okay, equation 1. Nitrogen gas plus 3 moles of ammonia will yield 2 moles of ammonia. And the enthalpy change of this particular reaction is negative 92 kilojoules. And we have the second chemical equation. 1 mole of H2O will be decomposed into hydrogen gas plus 1/2 mole of oxygen gas. And our enthalpy change of this particular reaction is positive 286 kilojoules. And now, what is the enthalpy change of the reaction, or the delta HRXN? And we have to find out. Okay. Now, in your visualization, you can see in equation number 2 that there is a fraction in terms of fraction. There's a mole in terms of fraction. There's 1/2. So this is the first identification that we need to avoid. Because in a chemical reaction, we need to avoid point something. It's not allowed in a chemical reaction, point something, blah, blah, blah. So number 2, it's not allowed to have a fractional form of number of moles. Though it is okay somewhere in elementary reactions, meaning temporary reactions or intermediate reactions, but in the overall chemical reactions, it should not appear. So meaning to say, we need to simplify further the chemical reaction so that we can have a fraction, whether improper fraction or proper fraction, right? Okay. Now, this is our first issue. There's a fraction and second equation. Now, our overall chemical reaction is 4 moles of ammonia plus 3 moles of oxygen plus 2 moles of nitrogen gas plus 6 moles of water. This is the chemical reaction we are trying to find out when we add equation number 1 and equation number 2, right? With its corresponding enthalpy change of reaction. The negative 92 and the positive 26. Now the first technique in Hess Law, first, we have to add the two equations. We go back first to the basic. Though we can solve directly, but I need to discuss it in a detailed fashion. Something like that. Okay, if we add directly these two equations, of course, you need to add also the two enthalpy of reactions of the equation 1 and equation 2. Okay, and it's very clear. Now I have to say like this, N2, okay, plus 3 moles of hydrogen gas is equals to 2 moles of ammonia, and then plus equation 2, water equal to hydrogen gas H2 plus 1/2 mole of oxygen gas. Then add this one if we try to yield the same overall chemical reaction as what presented by our problem. Okay, add now. The technique of adding, add the reactants first, all. Second, add all the products. Okay. Now in equation 1 you have N2 plus 3 moles of H2 plus 1 mole of water is equal to 2 moles of ammonia, mga palangga, plus 1 mole of H2 plus 1/2 mole of oxygen gas. Now add this perfectly if this is fitting to this chemical reaction presented above. Okay, so this one. Take note with the ammonia. There's no ammonia in the left. Okay, but it's in the right. H2O also, nothing. We cannot cancel out anything here. It's not totally the same here, right? So this is wrong. We go to option number 2. Okay, option number 2, we can reverse either equation 1 or equation 2, add them both to yield the same chemical reaction like this. Okay, like that. Okay, let's say reverse equation 1. Okay, 2 moles of ammonia is equal to 1 mole of nitrogen gas plus 3H2. Then add the equation 2. So H2O plus H2 plus 1/2 mole of oxygen gas. Then add the 2 moles of ammonia plus water is equal to nitrogen gas plus 3 moles of ammonia plus H2 plus 1/2 mole of oxygen gas. Take a look, it is the same chemical reaction. It's not also very clear. Okay? As you can visualize, very clear, not exactly the same. So, wrong. How about changing the 2? Okay? Reversing the 2 and add them both. Okay. Let's say 2NH3, okay, is equal to N2 plus 3H2. Then reverse H2 plus 1/2 mole of oxygen gas is equals to H2O. Add them both. So 2NH3 plus H2 plus 1/2 oxygen gas is equals to N2 plus H2O plus 3H2 in carbon. Okay, take a look, is it the same already or not? Okay, take a look. When you reverse the 2, it looks like they have the same similarities. But we need to do something in order one compound over the other elements to be cancelled out. So, for example, ammonia, there's also oxygen here. Perfect, there was oxygen here, right? And ammonia. And then the product also have nitrogen, also water, right? Right. And your problem, there's an H2 here. No problem, because if you try to multiply that to something and add, then it will be eliminated in the equation. Okay, so our third step is correct, but we have to manipulate by employing the multiplication of the number of moles to something. Okay, Now we reverse, so change this to positive 92, change it to negative 286 because you reverse to both. Okay, ganon. Now mga palangga, if that is the case, reverse mo ang tanan. Going back to equation 1 of equation 2. Okay, since you have 1/2 mole of oxygen gas in equation 2, take a look at equation 2. In my introductory discussion, we need to avoid the 1/2. What is the number you will be able to multiply by 1/2 an oxygen gas to make it a perfect figure? Equation 2. Okay, here. So let's take a look for this. Stay put for this because it looks like it's necessary. Okay, we go to equation number 2. So what is the number of moles to be multiplied? So you will say in your brain cells first, I can multiply this by 2 so that it will become oxygen gas. It's possible, of course. But take note, when you add to the equation 1, nobody cancels. Right? Because 2H2, 2H2O, and this is 3H2. Right? So you can never multiply 1/2 mole of oxygen gas to 2 because if you add this to equation 1, there's a 3. This is an odd number. It's impossible to cancel the H2 and the H2 here. Okay? How can you do that? So, go up a little bit. Say I'll say 3. So if you multiply 3 by 3 and 1/2, that is 3 halves. So it's not possible, a proper fraction. Okay. Go up a little bit. 4 moles. That is 4 over 2. So that is 2 moles of oxygen gas, 2 moles of H2, 2 moles of H2O. Because we need to multiply everything man gives siya. Okay. Now, so 2 moles of H2 is not also equal to 3H2 in equation 1. So go a little bit higher. 5. This is a trial and error method. 5. So 5 H2O, 5 H2, 5 halves. So it's not allowed also in proper fraction. Ikes, wale, because 5 halves. Okay, go to number 6. This is gonna be the proper way, starting from the minimal, going to the up. Until such time it will satisfy to equation number 1. Like that. So if you multiply this 6, so 6 moles of water is equal to 6 moles of hydrogen gas plus 3 moles of oxygen gas because you multiply this by 6. So 6 moles of H2O, 6 moles of H2, and 6 moles of 3 moles of O2. Now 6. Okay, put that here. Okay, so you have now 6 moles of water in equation 2. Okay, 6 moles of hydrogen gas plus 1/2 mole of oxygen gas. Now, you multiply this by 6 already, then your enthalpy change, your enthalpy of reaction in equation 2 will be multiplied also by 6. Okay, so calculator is 286 times 6. Meaning to say guys, every manipulation takes place, whether reversing the chemical equation or multiplying that a particular coefficient or number, you have also to manipulate your enthalpy of reaction of a particular equation. Something like that. So, we have 1,716 kilojoules. Okay, now, if we add this to the equation 1, what will happen? Okay, we have 6 moles of H2 and we have also 3 moles of H2. So it will never also equal. Then, the rule in chemistry, you don't have to go back. If you try already 2, 3, 4, 5, 6. So your last option is you always try to multiply the equation 1 to a particular something of number so that it will equal also to this 6H2O, 6H2 plus 1/2 oxygen gas. So, what particular number you will multiply to be equal to this terms? So, you start by 1. 1 more, 3, it cannot be happening because it's 6H2. 2 and 2, 6. You will multiply by 2. Okay, multiply this by 2, equation 1. Okay. So that you will become not error, multiply also directly your enthalpy change. No, enthalpy of reaction. So times 2. Because you will be wrong if you will never do that after. So like this, 92 times 2 is equal to 184 kilojoules mga talangga. So 184 kilojoules. Ganon. Okay. Like that. Okay. Now, I will write now the equation 1 here. This is 2N2. No, reverse. Because we reverse that, right? Okay. I said we reverse everything. Okay. So it will now become 4, 2, and to reverse everything. And H3. Wala be space, guys. No more space in my, whiteboard. So I have to erase like this, guys, ha? Just take note on your blank sheet of paper because I cannot explain very well like I will not erase. Nakakalata. Okay, it's gonna be 2 moles of nitrogen gas plus 6 moles of H2 is equals to 4 moles of ammonia. Equation 1. Then since we reverse that one, reverse this directly. So 4NH3, okay, 2N2 plus 6H2, right? Okay, 6H2, 2N2 for ammonia. So reverse this one. Remove this. Okay. Now, this is equation number 1. So equation number 2, multiply that by 6 as I told you a while ago. So again, reverse. It will become 3. Okay, 3O2 plus 3H2 is equal to 6 moles of water. Again, review. 6 times 1 half, 3. 6 times 2, 6H2. Okay, and 6 moles of water. Add them both. This is question number 2. Add them both because we already manipulated the H here, no problem. Right? Okay. So add them both. All reactants in the left, all products in the right. So we have 4 moles of ammonia, mga palangga, plus 3 moles of oxygen gas, plus 6 moles of hydrogen gas is equal to 2 moles of nitrogen gas, plus 6 moles of hydrogen gas, plus 6 moles of water. Take a look what are cancelable here. Okay, like that. 6H2 is cancelable. So what will be left? 4 moles of ammonia plus 3 moles of oxygen gas is equal to 2N2 gas plus 6H2O. Take a look if this is equal to the overall chemical reaction that we're trying to solve. Take a look. Okay, forms of ammonia, oxygen, nitrogen, perfect. It's already equal. So our solution is correct. Now this is the time we need to add now the enthalpy of reaction in each particular equation. So we said delta H of reaction is equal to the delta H in equation 1. Okay, which is equal to the positive 184 kilojoules, okay, plus the delta H in equation number 2. So this is going to be 1841 plus negative 1716 plus negative 1716. So calculator please. Ganon. So our answer is 1841. Plus, in math, if you subtract to a negative thing, that will become positive. Okay? 1716 is equals to 3557. So we have 3557. Okay. Enthalpy change of reaction. Okay, kilojoules. Enthalpy change of the reaction. Ganon. This one, 3557 kilojoules. Like that. Actually, guys, it's very lengthy also. That's why I never see this in the board examination. Okay? But I remember there is a direct, something like that, but it asks how to compute the, what are the mass, like this. But in a form like this also. Okay? Because sometimes in this problem, you can also add something here. For example, let me say, 2 grams of ammonia, what is the volume necessary in order for that to achieve at 3,500 kilojoules? So mag-documented na yung Ka. So makuha din mo na siya. Okay? Like that. You get the point? Mga ganang-ganang chuba-chucho. Okay. So kaya naman the chemical reactions, stoichiometric there is a number of moles. Okay, you get the point. Like that. In fact, you can also obtain the enthalpy of change of each element. For example, this hydrogen gas, you have an enthalpy of reaction of 1841. So you will say delta H of H2 is equal to this 1841, okay, divided by 3 moles of hydrogen gas. So this will be your change of hydrogen gas, enthalpy change of hydrogen gas individually. Okay, N2, H2, ammonia, water, H2, oxygen gas. Each element and compounds there has its own enthalpy change basing on the enthalpy of the reaction mentioned in the problem. Okay, so this will be a backup question already. Okay, after getting the enthalpy change of reaction, because not all the times enthalpy change of reaction will be obtained. Something also, what is the total mass of nitrogen gas obtained from the total enthalpy change of reaction? So you will use the enthalpy rate of reaction as your basis, not the individual na siya. So it depends how the question is being stated or phrased. Okay, so it will depend there, not on the, always for the sample problems. Like that. You get the point, mga palangga? Any questions so far? If you like this video, you can comment, you can like, you can share, and you can subscribe my YT channel if you are not subscribing yet, and you can click the notification bell of I am a senior, your voice. Bye bye everybody, God bless. See you later.